Alrighty, welcome to the first of 3 videos that I'm going to be doing which describe different kinds of chemical reactions. And today's reaction is, of course, the precipitation reaction. The first thing we're going to do with the precipitation reaction is just describe a really general picture of what occurs, how a precipitate forms, what exactly a precipitate is, etc., etc. So here we've got 2 aqueous solutions. We've got one yellow aqueous solution in this test tube up here, and one in this larger test tube down here. And an aqueous solution, we remember, is not just a liquid, it's actually ions from an ionic compound dissolved in water. So they're actually floating around disassociated. So aqueous solutions. And we're going to add the contents of this yellow, or we're going to add the contents of this test tube, this yellow substance, to our aqueous solution in this larger test tube. And what occurs is interesting. We still get a lot of water, we still have a lot of disassociated ions floating around in there, but we also have this yellow solid. Some of it's floating around in the water, some of it's collected at the bottom of the test tube. And in general, we call this solid that forms as the result of mixing 2 aqueous solutions a precipitate. And this reaction in general is called a precipitation reaction. So the formation of a solid from 2 aqueous solutions. But now let's dig a bit deeper and look at actually the kind of equation one of these reactions would yield. Here we've got one kind of aqueous substance. We've got silver nitrate. Silver nitrate, we're going to be adding it to a solution of potassium chloride. So maybe you can think of the solution in here as silver nitrate and the solution in here, this yellow solution, as, as potassium chloride. This solid that's going to be formed is going to be silver chloride. In reality, silver chloride is a more silvery substance, but you can pretend it's yellow. And then we're also going to have some aqueous potassium nitrate left over. And so just to recap, this silver chloride is our precipitate. And both of our reactants begin the reaction as aqueous solutions. So they're really disassociated ions. It's not, this description of silver nitrate and potassium chloride isn't completely true, because in solution, when these solutions are in an aqueous state, they're not actually joined together to form these compounds, they're just floating ions. And so what we use to more accurately describe a precipitation reaction is something called an ionic equation, in this case a complete ionic equation. And all a complete ionic equation is we're just describing the compounds which are used as reactants. Instead of describing them as compounds, we're just describing them as ions. So here we've got some silver ions, we've got some nitrate ions, some potassium ions, and some chloride ions. And on the right-hand side of the equation, the product side, we've got silver chloride, our precipitate, and then instead of potassium nitrate, we've got potassium ions and nitrate ions. So this is our precipitate, silver chloride. But there's one interesting thing we should note here. Let's look at both sides of the equations. We know that the silver ions end up in silver chloride. We know that the chlorine ions or the chloride ions end up in silver chloride. But what about these nitrate ions and these potassium ions? Well, we see that they're in exactly the same state on the left-hand side of the equation as they are on the right. They don't do anything. They don't even participate in the reaction. And what we call these ions that just sort of are there for the ride, that just stick around, we call them spectator ions. They're just watching the reaction occur. They're watching the action occur between silver and chloride. So these are spectator ions. And so we can actually describe this equation or this reaction in another way, another kind of ionic equation, and we call this the net ionic equation. We call it a net ionic equation because we essentially, all we're doing is just excluding the spectator ions. We're just writing exactly this reaction, but we're going to exclude nitrate and potassium from both sides of the equation. And all we're going to get, or rather all our net ionic equation is going to be, it's just going to be silver ions, aqueous silver ions, aqueous chloride ions as the reactants, and then our product is our precipitate, silver chloride, and that's a solid. So this is a net ionic equation. Now let's look at another precipitation reaction equation. Let's say I gave you this. Let's say I told you that potassium hydroxide combines with iron nitrate in a precipitation reaction, and I balanced this for you. What is the substance that's going to be produced as the precipitate? Well, we don't know. We have to do a little bit of investigative work to figure that out. And so let's sketch what some potential solutions might be. We know we've got 4 ions in this case floating around in solution before the reaction occurs. We've got potassium ions, we've got hydroxide ions, we have lead ions, and they have a charge of 3+ because it takes 3 nitrates with a charge of 1- to balance them, and then we've got some nitrate ions. How are these going to combine? Well, first of all, it's easy to say we know potassium is not going to combine with iron because they're both positive, and you can't have 2 cations joined together to form a compound. We also know that in the resulting reaction, we're not going to have potassium again combined with hydroxide because that would be a reactant, and then it wouldn't be a product if it were formed again. It wouldn't be involved in the chemical reaction. So we know probably, in fact we know with certainty, that if this reaction occurs, potassium is going to combine with nitrate. Potassium is going to combine with nitrate, and hydroxide is going to combine with iron. So we're going to have 2 products formed, 2 resulting compounds. We're going to have iron hydroxide, and potassium nitrate. The question is, which of these is our precipitate? Either one could be. We don't have enough information at this point. We haven't seen the reaction take place to definitively state which is the precipitate. To do this, we need to take a look at some further information. And this information, these are called solubility rules. There are a few of them, and unfortunately, as a chemistry student, you really don't have many options but to memorize these, particularly if you're going to take the AP exam. The writers of the test assume you have most of these memorized. And if you do them enough, you do these kind of problems enough, this shouldn't be too difficult. But let's just go through them one by one. So most of the time, nitrate salts are soluble. Most of the time, anything containing an alkali metal in salt form, that just means it's bound to an anion, as the cation, is soluble. Similarly, ammonium salts, remember that ammonium is just this polyatomic ion NH4+. Any ammonium salt is generally going to be soluble, so it's not going to form a precipitate. Also, these 3 halogens, chlorine, bromine, and iodine, tend to form soluble compounds with other elements, except, there's one exception, or a few exceptions to this general rule, except when these elements combine with silver, lead, or mercury. Silver, lead, or mercury. With these halogens produce insoluble compounds. And also in general, sulfate salts are soluble. Insoluble compounds, most of the time hydroxide produces insoluble compounds. There are a couple exceptions, except potassium hydroxide and sodium hydroxide. These are, of course, more commonly known as Li, and they're strong bases, so they dissociate completely in water. Most sulfide, carbonate, chromate, and phosphate salts are insoluble. And this is perhaps my favorite solubility rule. It's the one a lot of times textbooks leave out, but I think it's the most useful, and it's the one that comes up the most often. Most of the time, whenever you have a transition metal in a compound that it's produced in a precipitation reaction, most of the time that transition metal is going to produce an insoluble, brightly colored precipitate. And I would really say, if you're going to remember 2 of these, you should remember this one and this one. Nitrates come up a lot, and transition metals come up a lot. And we'll see that if we go back to our previous example. Here we've got potassium nitrate. So potassium, we know, is an alkali metal. So that's one rule telling us it's soluble. We've also got nitrate here. And we know, as I just said, most nitrate salts are soluble. So we can probably say that potassium nitrate is not the precipitate, and so these 2 ions are spectator ions. And similarly, if we look at iron hydroxide, well, I just told you that most compounds with transition metals, iron being one, are insoluble. Also, hydroxides, except in potassium hydroxide and sodium hydroxide, their compounds are insoluble. So for 2 reasons again, iron hydroxide is most likely our precipitate. And again, you'll get more comfortable with these rules as you do more and more of these problems. Your teacher might not even require you to memorize them if they are benevolent. But now, just to drive some of these points home and get them stored in your long-term memory, let's just do a quick problem. So pause this video, rewind if you need to, and I'll be here when you've got an answer. Alrighty, welcome back. Let's see if we can tackle this problem together. It's not too involved, but we'll go through it step by step. The first thing we need to do is figure out what formulas potassium iodide and lead nitrate take. And you're a pro at this by now. This should be pretty simple. We know potassium iodide is Ki. Lead nitrate with an oxidation state or a charge of +2 on the lead ion is just going to be PbNO3 2. And let's first of all write the simple equation for this precipitation reaction. We know we've got some aqueous potassium iodide with some aqueous lead nitrate, and they produce, we know this potassium is going to match up with this nitrate, so we're going to have potassium nitrate and lead iodide, and we need 2 iodide ions to match the +2 on the lead ion. If we quickly balance this, we'll soon see that we need 2 potassium iodides and 2 potassium nitrates. There we go, that all balances. Now our question becomes, which of the 2 is the precipitate? Because remember, to answer this question, to find the net ionic equation for this precipitation reaction, we need to know, well, which ions are spectator ions and which product compound is the precipitate. And so we can take a look back at our solubility rules. Alrighty, so in the context of these compounds, we've got an alkali metal here, and we've got a nitrate group here, and we know that alkali metals and nitrates are generally soluble, so this is probably soluble. Similarly, we've got a transition metal here, and we've got iodide here, so this is interesting. I told you that most iodide salts are soluble. However, this falls under the category of an exception. Whenever we have lead with iodide, that compound is generally insoluble. So this lead iodide is our precipitate. It actually makes a gorgeous yellow precipitate in solution. And now to finish up, we just need to write our net ionic equation. So in this case, we're going to be excluding potassium and nitrate from our net ionic equation. So we're just going to have 2 iodide ions in solution plus 1 lead ion in solution. And that's going to give us 1 lead iodide formula unit as a solid, and this is going to be our precipitate. So thank you very much, and I will see you in the next video.